A system of equations is a set of two or more equations that are to be solved simultaneously. A solution of the system must also be a solution of every individual equation in the system. Let's look at a brief example. Is the ordered pair 4, -5 a solution of the system of two equations shown on this slide? In order to answer this question, we need to test the ordered pair in both equations, and only if it makes both equations true is it a solution of the system. First, let's test the ordered pair 4, -5 in the equation x minus y equals 9. We can replace x with 4 and y with -5. And when we do so, we see that the equation 4 plus 5 equals 9 is true. Therefore, the ordered pair 4, -5 is a solution of that equation. But we don't yet know if it's a solution of the system. We need to test it in our second equation, 3x plus y equals 8. So again, we replace x with 4 and y with -5. In this case, 12 plus -5 does not equal 8. The equation is not true. So 4, -5 is not a solution of that second equation, and therefore it's also not a solution of the system of equations. One way in which we can solve a system of two linear equations is to graph both lines on the same coordinate plane. The solution to the system is the ordered pair that is the intersection point of the two lines. We can see from the example on the slide, the blue line contains all the solutions of the equation y equals x minus 1. And the red line contains all the solutions of the equation y equals -2x plus 5. Only the point 2, 1, the intersection point, is on both of the lines, and therefore that's the only point that is a solution of both equations. This makes it the solution of the system. And we can verify that it is a solution of the system by testing the point in both of the equations. So in the equation y equals x minus 1, if we replace y with 1 and x with 2, we see that the equation is true. 1 equals 2 minus 1. In the same way, in the equation y equals -2x plus 5, if we replace y with 1 and x with 2, we see that 1 equals -4 plus 5, which is also true. So the ordered pair 2, 1 is a solution of the system. Now let's look at an example in which we solve the system by graphing the lines first and identifying that point of intersection. The first equation in our system, which we'll graph in blue, is y equals x plus 5. We could graph this equation by making a table of x and y values, or we could notice that the equation is written in slope-intercept form, y equals mx plus b. And the slope of our equation then is the coefficient of x, which is 1, and the y-intercept is the point 0, 5. So we graph the point 0, 5, and we can use the slope to identify other points on our line. Connecting these points, we see the graph of our first equation. Now let's look at the second equation. We'll graph it in red, x plus 2y equals 4. One way in which to draw the graph would be to put this equation into slope-intercept form by solving for y. However, we can also draw the graph quickly by identifying the x and y intercepts. Remember, to find the x-intercept of an equation, we let y equal 0. In this case, if y equals 0, the equation is simply x equals 4. So our x-intercept is the point 4, 0. Then to find the y-intercept, we let x equal 0, in which case we have the equation 2y equals 4, or y equals 2. So the y-intercept of this line is the point 0, 2. And we can graph the line by plotting those 2 points and then drawing a line through them. Once we've drawn the graph of both lines, we can easily identify the intersection point. It's right here, the point -2, 3. Since that's the intersection point of the two lines, It's also a solution of both equations, and therefore we can say that the ordered pair -2, 3 is the solution of this system of equations.